Dear students, welcome to a new session on database management system, and the topic of the session is aggregate functions. The outcome is that at the end of the session you will be able to explain the working of various aggregate functions. First of all, we will see what is meant by aggregate function. Aggregate is what you call it for a collection. Here also, aggregate functions are those functions that take a collection of values. It can be a set or multiple sets of values as input, and that will give you as output a single value. So always the output of the aggregate functions will be a single value. And the structured query language offers 5 different built-in functions. These are the 5 different built-in functions. Average, represented by AVG, it's a function. Minimum, min, maximum, max, total, sum, count by count. So these are the aggregate functions that take multiple input and give you a single output. The input to sum and average must be always a collection of numbers. Only then you can find the sum and average of all those numbers. But the other operations like minimum, maximum and count, they can operate on collection of non-numeric data also, like strings as well as. So let us discuss all these things with the help of queries. You are given a task to find the average salary of the instructors in the computer science department. So the input for this query will be instructors, that is a relation or a table, and there will be a department called as computer science. So you have to identify those instructors who are in the computer science department alone and find the average salary of those instructors. So here is the query. Select, it is used to get the result or select some tuples from the instructor table and find the average of the salary of the instructors from the instructor table, and there is a condition specified in the var class, that is the department name is equal to computer science. So what this query will do is that it will get the list of instructors who are having the department name as computer science. From the list of tuples, it will get the salary and find average of those salary. So that is the work of this query. Select average of salary. So this will be the output of this particular query. Since it is an aggregate function, this will give you a single value, that is the average value, which is applied on the instructor table, and the condition is that you have to select the tuples only those who are having the department name as computer science. The result of this query is a relation which is with a single attribute containing a single tuple with a numerical value corresponding to the average salary of instructors in the computer science department. So you will get only the single value, which is the average of all those salaries of the instructors in the computer science department. So the result of this query will be a table containing the attribute as that is the column name as average of salary. So when you want to rename this attribute, you can write as select average of salary as average salary. So you'll get the value with the heading as average salary. So that's the difference between this query and this query. So you can use as class for specifying the name of the column in the result. Retaining duplicates is important in computing an average. You have to compute the average for duplicate tuples also. For example, in the instructor relation, the salary in the computer science department can be 75,000, 65,000, 92,000 and 2,32,000. It's 3 values. The average balance is these 3 values put together divided by 3. So you get the average salary like this. So when there is a new instructor, which is the 4th instructor, when he is added to the computer science department, and if the salary happens to be 75,000, this 75,000 is same as the first instructor's salary 75,000. So you should not remove this considering it as a duplicate. If the duplicates were eliminated, you would obtain the wrong answer, because two instructors can have the same salary, that is permitted. So when you are removing this, you will be finding the average upon 4 tuples, so you will get the average as 55,000. But the correct answer would be all these values together with 75,000 divided by 4, so it will be 76,750. So that will be the result. So in average, you should not remove the duplicates. There are cases where we must eliminate the duplicates before computing aggregate function. There are some places where we need to eliminate the duplicates. So in those cases, we can use the keyword distinct. Okay, so find the total number of instructors who teach a course in spring 2010 semester. So we have to find the number of instructors who are teaching the course in this particular semester. So the output of this will be the count. Total number means it is the count. So the single instructor, for example, instructor with the ID 12 can be teaching 2 courses. Here we have to find only the number of instructors, not the number of courses. So if the instructor is repeated, you have to eliminate that duplicate. So for that, I am going to use the distinct keyword. So this query will select the count of the ID, which is distinct after removing the duplicates, from the relation with a table, that is teachers, and the condition is that the semester has to be spring and the year has to be 2010. So this is how the query eliminates the duplicates with the help of distinct. Because of the keyword distinct preceding ID, even if an instructor teaches more than one course, C is counted only once in the result. That is where the use of distinct happens. The next is, for selecting all the tuples, we can use star notation. We use the aggregate function count frequently to count the number of tuples in the relation. For example, if you want to list all the tuples in a table, you will give like select star from course. So that will list out all the tuples from the course relation. So if you want to find the number of tuples in the course relation, you can write like select count of star. Star indicates all the tuples from course. So counting the number of tuples after selection. So that will be the output. So the number of tuples in the course relation will be printed. The next is aggregate with grouping. You can group some tuples with the help of group by. So to apply the aggregate function not only on a single set of tuples, we can also apply on a group of or the set of tuples using the group by class. Tuples with the same value on the attribute, on all attributes in the group by class are placed in one group. For example, here find the average salary in each department. Here the computer science department average salary has to be separately given, and at the same time the EEE department instructor salary has to be given separately. For every department you have to calculate the average salary separately. For this, I am going to group by department name. All the instructors who are in the same department will be grouped together, and the average of those instructors will be calculated, and against the department name, if it is computer science, the department name computer science along with the average salary will be listed. So here select department name comma average of salary, and this average of salary is given as average salary as heading from the instructor column, and this is grouped by department name. So this group by is to group all the tuples who are in the same department together and find the average on that particular group alone. So for every group this will be done. So that is the use of group by class. The tuples in the instructor relation grouped by the department name attribute, which is the first step in computing the query result. So first step is to group the tuples, then the specified aggregate function is applied on each group. Whereas you have one more thing, find the average salary of all instructors. So this, there is no segregation based on the department name. So here it goes like select average of salary from instructor. So the entire relations will be considered as a single group here. Since there is no group by class, all the instructor tuples will be grouped into a single relation, and average of salary on all the tuples will be calculated. Here is the next example. Find the number of instructors in each department who teach a course in spring 2010 semester. So we have already worked out for a part of this query. So we have found out the number of instructors in the entire organization who taught the courses in spring 2010. Now you have to add a condition that you have to identify based on the departments. For each department, what is the number of instructors? So information about which instructor teach which course sections in which semester is available in the teachers relation. So we have used the teachers relation. So we have already discussed about the relational algebra operations. There you had the join operation. So this join operation, first it combines the instructor table and the teachers table based on the ID. So the teacher ID will be in the instructor table and also in the teachers table. So based on that there will be a join performed, and after that you will be selecting the department name and the count of the IDs, distinct IDs. Duplicates has to be removed because you are going to count only the number of teachers. So the distinct ID will be taken as instructor count. The name of this particular result, count result, will be given as instructor count as the column heading. So this will select the department name and the instructor count. So you will have two columns in the result, and from the instructor teachers join you are going to perform this operation, and the condition is that only the tuples having the semester as spring and the year as 2010 will be taken, and this will be grouped by department name. So at the end of this operations you will get the department name and the instructor count. So if it is CSE 10, which means that there are 10 instructors who taught the courses in spring 2010. After that, from the EEE department, 12 instructors. Likewise, for each and every department, you will get the number of instructors who taught in the spring 2010 semester. Ensure that only attributes that appear in the select statement without being aggregated are those that are present in the group by. So here this select class contains the attribute department name. So this is not taken for aggregate function, only the ID is taken for aggregate function. This attribute which is not in the group by, not in the aggregate function, is present in the group by class. Only then the output will be correct. See here, this is a erroneous output because here select department name, ID, average of salary from instructor, group by department name. Each instructor in a particular group defined by the department name can have a different ID. Since only one tuple is output for each group, there is no unique way of choosing which ID value to output. As a result, such cases are disallowed in SQL. The next is having class. It is useful to state a condition that applies to groups rather than the tuples. So till now when we have used the where condition, that condition will be applied on a tuple, not on a group. So when you want to apply some conditions on the groups which are grouped by group by class, you have to use the having class. Consider the example. Find those departments where the average salary of the instructor is more than 42,000. So you have to find the department where average salary is. So here you are having three tasks. One is you have to group the tuples based on the department. That is the first activity. And the second activity is to find the average of the salary, but you have to apply the condition as above 42,000. So you have three important things to be done. This condition does not apply to a single tuple, rather than it applies to each group constructed by the group by class. The first is you have to group the tuples based on the department, and after doing that you have to list only the tuples which are having the salary greater than 42,000, and after that the aggregate function will be applied. First is group by, then take only the tuples which satisfy the condition in the having class in each of these groups, and finally apply aggregate function on each of these groups. So you have to perform all these three activities in a particular sequence. Select department name, average of salary as average salary. So this will be taken as average salary. So in the output you will get department name as one column and average salary as another column, where the average salary is calculated by using the average of salary aggregate function. So this is from the instructor department. So this takes only the tuples from the instructor department. All the details are available in the instructor department itself, and you have to group by department name. Computer science, EEE, ECE, like that you have to combine the tuples of particular departments, and in that, after combining as departments, you have to apply the condition that the salary is greater than 42,000. Only those tuples having the salary greater than 42,000 in each group will be taken for this aggregate function. Any attribute that is present in the having class without being aggregated must appear in the group by class, otherwise the query is treated as erroneous one. This we have already discussed. So see here, without the thing which is not being aggregated must appear in the group by. So this is aggregated attribute that appears in the having class, and this is not an aggregated one that has to appear in the group by. This you have to keep in mind always. Those things that were not aggregated has to appear in the group by, and that is aggregated has to appear in the having class. So the sequence of operations will be like the meaning of query containing the aggregation, group by or having class is defined by the following sequence. So this you have to have it as a sequence of operations, one after the other you have to perform. As was the case for queries without the aggregate, the from class is first evaluated to get a relation. So you have to get the tuples from the from class, where that gets the details from the table which is specified in the from class. If a where class is present, the predicate in the where class is applied on the result of the relation from the from class. From the table or the relation you will get some tuples, and on that tuples you will apply the condition which is in the where class if the where class is present. And after this thing you will get some tuples which satisfy the condition in the predicate of where class. Then it will be grouped based on your group by class. If this group by class is absent, then the entire set of tuples from the where class will be treated as single group. If there is no group by, then entire relations will be taken as single group. If there is group by, then based on the attributes you will have the number of groups. And if the having class is present, then the predicate in the having class is applied to each group. This is the fourth step. The groups that do not satisfy the having class predicates will be removed. If this condition is not satisfied, then all these group tuples will be removed. The select class uses the remaining groups to generate the tuple of result of the query, applying the aggregate function to get a single result tuple for each group. So first is from class, then it is select class, then it is where, from, where, group by, having, and finally the aggregate function on the select class attributes. So this is how you have to apply as a sequence of operations. So aggregation with the null and boolean values. So null values will appear in your tuples. Null values, when they they are present in the relations, they will complicate the processing of the aggregate function. Wherever you have null values, that will definitely complicate your operations. Here also in case of aggregate functions, it will complicate your result. SQL standard says that the sum operator should ignore null values in the input. If the null values are present in your input, then the sum operator should not use your null values. Aggregate functions treat nulls according to the following rule. All aggregate functions except count ignore the null values, but the count function will not ignore the null values. As a result of null values being ignored, the collection of values may be empty. If all the values are null, then the result may also be null. The count of an empty collection is defined to be 0, and all other aggregate operations return a value of null when applied on an empty collection. If you are going to do any operation on empty collection, definitely you will get the value as null. But in case of count, you will give it as 0. There is nothing in the no tuples in the relation, so you will get 0 as the count. A Boolean data type that can take values true, false and unknown was introduced in SQL. So you have a Boolean data type which initially takes only the values true and false, but after having these null values, a new type unknown was introduced into Boolean data type in the standard 1999 standard of SQL. Okay, this was a lengthy topic, so we have discussed 5 different aggregate function and how this can be applied. This is the reference book, you can refer it there. Thank you.